Hello everyone. Today I'm going to how to design an antenna, probably a microstrip patch antenna on HFSS. Now it is we call this Ansys Electronics Desktop. I'm going to choose 5G broadband antenna. The structure, if you see the structure of an antenna, here's the structure. Those are basically designed two antennas. If you see one antenna, the first antenna is like this, and the second antenna is quite smaller one compared to the base model. And the other provided two different dimensions for the both antennas. Is the first dimension, and at the same time you can see here the second dimensions. The basic structure is the same, but only some of the dimensions are changed. Okay, as we know, we have a lot of softwares for designing an antenna and simulation. Most of the designing engineers are using CST, and some of the designing engineers are using ANSYS. Uh, it is depending upon the way the equations are solved. Okay, I personally choose ANSYS. Uh, um, I got around 90% of accuracy on using an ANSYS in the practical sessions. Okay, so the software what I'm using, go to new project is opened. So choose HFSS. Okay, this is the plane where we're going to design an antenna. Here the issue is we're going to there are probably two ways to design an antenna. So one thing is you can place an antenna something like this. Okay, the horizon at the middle. There is another way to design an antenna is the horizon at the side and the antenna is designed somewhere here, somewhere here, somewhere here, and somewhere here, and here. The four quadrants you can choose any quadrant to place an antenna design. Most of the design engineers are preferably use this quadrant to place. We all know the microstrip patch antenna is a sandwich material. The bottom there is a ground plane, middle there is a substrate, at the top there is a radiating element is placed on the top of the patch. Okay, so now take a cube. Okay, name it as you can see here. Name that box as substrate. Uh, Next now is the create box. Here, see, here you can see the dimensions. First, initially, um, command is create box. Coordinate system is global. The coordinate system means where the box is initially started. We can add multiple coordinates according to your requirement. We'll discuss later on why I choose the global coordinates. Okay, this is the position where I place the box. Is the x direction, the length, how much amount of length is uh, happening in the x direction, in the same way in the y direction, and the thickness in the z direction. So I place say for the x direction some length of 6 mm. At the same time towards the y the same length of 6 mm. The thickness on the paper it is described it is 1.68 millimeters. Say thickness small t, for capital T, it is 1.65 mm thickness. Okay, see, this is here. If I change if I change the position from the x, it is 0. If I change to from 0 to 0.5, the entire structure goes down. See what's happening if I change from 0 to 1.5. See the difference. Okay, this is the initial position where entire structure is going to be placed. If I change y as well, the entire structure moves towards this direction. See, like this one. Or if I place negative sign here, here it is. Okay, very good. On the paper, you can see the antenna is placed on top of the substrate. Now, um, for this antenna, I'm going to design and dimensions from bottom to top. At the bottom, we can see that L5 length and the width of around W2. The same way, open here. Some of the programmers, some of the designers, if I say, they're choosing planes to place the top radiating element or the bottom ground plane. But my personal practical experience is, at least if I say, if I paint my wall, okay, one simple brush coating, at least it's a minimum thickness of at least 0.01 mm, the minimum. In a practical sense, on the top of the substrate, there is a copper plate is there, but usually we are using the copper. Maintain a minimum thickness for the better results. Okay, some of the programmers may use, some of the programmers may not, but I personally choose on the top of the substrate, place a radiating element. That radiating element thickness must be minimum. Okay, so I'm going to take a box, create it. Okay, see, here is the place. Now I'm going to start at the initial position. Okay, from T. See, my new box is placed on the top of the previous substrate thickness. Okay, now on the Z direction, I'm going to place as material thickness MT. Let me say it is 0.125 millimeter thickness. You can choose according to your requirement. Okay, a minimum thickness I placed. Okay, next. If you see on the paper, the entire structure is placed on the middle of this substrate. On the middle of this substrate. Okay, so in the same way, we are also placed entire structure on the middle. Okay, we are taking it as length on the middle. Okay, now see, the box is started at the middle of the substrate. Okay, now again, see on the paper, it is described that at the bottom the width is W2. See, the width W2 is 1.41. Open here on the direction, W2 is 1.41 millimeters is already here. Okay, you can measure, go to measure position from here to here. You can see on the left hand direction the distance is 1.41 mm. Now we are in a good to go. Next, if you see, the entire structure is started at the middle. The box is started at the middle of the substrate, but this box is not at the middle of the substrate. It is starting at the middle of the substrate. The box is not at the middle of the substrate. So that's why I'm going to take y direction substrate, that W2 by 2. Okay. Now check whether it is correct or not. Going to measure position from 0 to here. It is distance 2.29. From at the rightmost to here, it is 2.29. Now we are good to go. Okay, next. See, the structure is at the bottom. The length is L5. L5 is 0.49. Okay, select this one. It is L5 0.49 mm width. Apply. Here it is. But our intention is to place the bottom plate at the last portion of the substrate. For that, just simply add towards the x direction, start at substrate length. Now see, the bottom plate is placed starting from the end of the substrate. But unfortunately, we need to fold towards the substrate. So that's why here towards the x, put a negative sign here. That's it. I'm going to save my project. Good. Okay, next one. We're going to add this one on top of this L5. Okay, the same way, go to boxes, draw the box. As we know, it is started at the thickness of the substrate. On the top, we're adding as a metal thickness. Okay, towards the right is W2. At the same time, it is starting at the right is length by 2 minus W2 by 2. Okay, here's the grid point is the total length is L2. It is 9.97. L2, it is 9.97. mm is already there, units. Very good. But here is the issue, the starting portion. We need to start, as we discussed earlier, we need to start at length. Okay, fit all. Now we are going to add this feed line on the top of this L5. For that, put L2 and put a negative sign here. So, but unfortunately it started at the end of the substrate. But our intention is to place this on the top. That's why add this length before the X. So that, okay, sorry. This is going to be start and the top of this entire structure. Okay. Now we're going to add L3 on the top of this structure. Now there's no other way, just put some copy and paste. Okay, but this is started at L3. Mentioned L3 is 0.77. Okay, go to here, it is 0.77 millimeters. Hit OK. Add here, it is L2. Now see, it is L2. But as a tricky thing, we need to subtract from W2 to the distance is S2. Okay, go to here, 2 minus S2. On the paper, S2 is 0.02. It is 0.02 millimeter. On the both sides, it is 0.02. But we need to subtract that S2 in the starting position, so minus S2. Sorry, I need to add this one. Measure position from here to here, it is 0.02. Perfect. On this side, measure position here to here, it is 0.02 mm. Perfect. Go to paper, S2 is 0.02. Now add on the top, we just add L4. Okay, go to here, okay, copy and paste. Now see, the length is L4. On the paper, L4 is 0.7 mm. Add 0.7 mm. Okay, hit apply. Minus L3. We need to subtract the distance is S1. S, which is how much? 0.34. S1 is 0.34 millimeter. Likewise here, S1. Great. Now we are going to place our real radiating patch on the top of the entire structure. But on the paper they are not mentioned where we are going to start structure. Okay, so for that I'm being just created one radiating box. See, I'm going to calculate that one. I'm going to place a radiating box somewhere on the top of the substrate. On the top of the substrate thickness is T. I'm going to choose the metal thickness is MT. Okay, now on the y direction, W1 1.9 mm. Go to here on the y direction, this W1 it is 1.9 mm is already there. Okay, on the y it is 1.9. Towards the x, L1 is 1.49. Great box, it is L1 1.49 millimeter. Here I am going to place this box file on the top of this feed line. Okay, so initially I know that the length of the substrate should be half, so that the entire radiating element is started at the middle of the substrate. Now I'm going to subtract this width W1 by 2 so that it is at the middle of this entire substrate. Now my task is to move this box, radiating box, into this area. I don't know, on the paper they had not mentioned somewhere it started. So, but they had mentioned LS1. Okay, they mentioned LS1. See, I'm going to start from the bottom first of all at the length ln. Okay, now if I place minus here, it started somewhere here. Now I'm going to subtract the first one L5. It starts here L5. Next 2, 3, 4. L5 minus L2 minus L3 minus L4. It is started on the top of this structure, but I need to subtract LS1 from here. So subtract LS1, that is LS1 0.33 millimeters plus LS1, sorry, plus LS1, that is 0.33 millimeters. Hit apply. Now you can see we can measure how much distance from here to here. 0.33 on an average. Okay, very good. Now I'm going to subtract a piece of metal from this box number 5 by simply creating a new box. That new box I'm going to subtract I'm going to subtract this piece of metal, this piece of metal from the entire structure. Okay, for that purpose I'm going to create this box, and then I'm going to subtract from this to this. Okay, you can see the width is ws1, the width of this new box is wx1, ws1, ws1 is mentioned, it is 0.88, 0.88 millimeters already there, but that should be start at the thickness, that should be ended with the thickness of metal thickness MD. Okay, now the height of this subtract is mentioned is ls1. Go to here, place ls1. Okay, very good. Towards the y direction, from the length alien by 2 minus ws1 by 2. Now I'm going to place the entire structure from here to here. Just go to box number 5, copy this one and paste here. Put a negative sign. That's it. This is the place where I need to subtract. Okay, just select box number 5 and then box number 6. Go to subtract. Just hit OK. You will see the subtracted material. Now I'm going to unite entire from box 1, box 2, 3, 4, 5. Unite. Here is your designed patch. Is there any ground plane are there? Just find ROU in the ground. Unfortunately, author is not mentioned anything about the ground. See ground. It is a proposed antenna has a rectangular radiating patch. Design. The paper they are not mentioned anything about the ground. Unfortunately. Yeah, anyway, this is how we are going to design an antenna on Ansys. I'm not diving deep into the simulation part because there is lot more videos are available on the internet, so that's why I'm not going to deep into the simulation part. Designing is difficult. Once we design an antenna, the simulation is going to be done by your software itself. If you have a skill to design this particular antenna, you can simulate. You can simulate anything. The concept of simulating is not changed at all, but the way you are designed is different. Say for example, if I say the length is already put it here, just go to HFSS, design properties, you can see those many variables that are used in this particular project. If I say the length. Okay, if I want to change the length from 18 to 20, you can observe the entire antenna is increased. Okay, if I say if I change the value from 20 to 50, see, then the radiating element is placed at the middle of the substrate. At the same time, it is stick on to the place where we mentioned earlier. If I say if I'm going to change say like thickness, say from 1.65 to say, wait, go to HFSS design properties. I'm going to change the thickness from 1.6 to say 5 mm. You can see the entire structure, the thickness is changed but remaining or not changed. Okay, if you have a knowledge on how you're going to design an antenna, it is very easy for you. Okay, it is very easy for you to parametric analysis parametric analysis so that minute changes can change the bandwidth, can change the physical parameters of an antenna. Very huge. So just learn the concept how to design an antenna so that you can do miracles. Anyway, thanks for watching. Good night.